communication for local area networks. Well, isn't that nice to know? It's as simple as that. It took me a long time to find this simple definition. You'd be surprised how many definitions of Ethernet are out there. This was the simplest one that made sense. It's just a set of standards, standard rules. That's all. If you want to talk on the Ethernet with other people who are on Ethernet, have the same rules as they do, and you guys will be able to communicate just fine. Don't have the same rules, you're not going to be able to communicate. The other devices will just drop the traffic. Or you won't be able to even read the traffic that's coming to you, either or. Domains and collision domains. So when you saw my diagram that we had before with the 6 switches, a broadcast, what does a switch do with a broadcast? It sends it out all ports except the one it came in on. Now, if that's what a broadcast message does, let's think about this. A router will never forward a broadcast message. It never will. But the router will get the broadcast messages. So if the router will get the broadcast messages and never forwards them on, that means this is pretty much the edge of your broadcast. And since a switch will forward a broadcast out every port, how far does that broadcast go? That will come into here, go out this port, go out this port, go out this port. And these are PCs, so these are the edge of your network as well. So this is where you have your broadcast domain. We call it a broadcast domain because when this PC1, sends a broadcast, the distance that the broadcast will travel is your domain. That broadcast will come through up to this PC, up through here, up to here, and up to this router. And then the router will not forward it. So this router, when you put a router in place, you really are stopping that broadcast traffic from going any farther. Now, we already learned that our collisions domains are really from the switch port to the PC. That's great, because there's no point in even having CSMA-CD anymore, considering the fact that we have full duplex going on, and our collisions are only to the switch port out to the edge device. Now, this, again, is another broadcast domain. As you can see, broadcast comes out from this PC. It's definitely going to go out this one. A broadcast, what does a switch do with a broadcast? Sends it out every port except the one it came in on, and then it'll stop right here at the router. So this is another broadcast domain. This is the same thing, no difference. This is a hub, so it doesn't really matter what type of message it is, because a hub sends traffic to all ports anyway, whether it's a broadcast or not. It's just a layer 1 device. It makes no forwarding decisions. It just sends it out to everyone. It's just like taking all the wires and just bundling them together. So this broadcast message is just definitely going to go here, and there we go. Now, the only difference that we have to worry about here, besides the broadcast domain, is our collision domain. With a switch, each one of these switch ports are its own collision domain. So that means even this switch port going to this router, it's its own collision domain. So right now, if we counted these collisions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we have 10 so far. But what about this one down here? Because we have a hub sitting down here. And if we have a hub sitting down here, this is going to act a little different. Because, remember, this isn't a switch port. This is half duplex. It's a hub. So it's half duplex. And if when PC1 sits over here and brings that data in, guess what? It's going to all of them, no matter what the data is. So if any one of these communicate at the same time, it will collide within this hub. That makes this hub and everything that connects to it, notice what I said. This makes this hub and everything that connects to it its own collision domain. So here we have, because these are switches, switch 1, switch 2. We have one collision here, we got 2, we got 3, we got 4, we got 5, we got 6, we got 7, we got 8, we got 9, we have 10, and we have 11. So all in all, we have 11 collisions domain. This PC, and this PC is all on one collision domain, including this router. This router's interface. This you need to know. You need to know the difference between a broadcast and a collision domain, and you should be able to get a diagram like this and recognize what is a collision and what is a broadcast domain, and be able to answer the question, how many collision domains and how many broadcast domains are there. Now, we saw these values as far as our MAC addresses, and we see that they're actually these weird numbers. MAC addresses have different names. They're called layer 2 addresses, Ethernet addresses, physical addresses, burnt-in addresses, and hardware addresses. Now, our burnt-in addresses can also say BAI. Each one of these MAC addresses have 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each one of these numbers can have a value of 0 to 9 or A through F. The reason why we go from A to F is because each one of these places has the possibility of 15, a value of 15. 0 through 15. So let's write this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So, this is pretty easy. Don't forget our zero here. This is pretty easy because 0 through 9 are going to match up. But I only have one place to put this digit. I can't write the number 10 as 10. I can't do that because I only have one place. So now, my 10 and my 11 and my 12, 13, 14, and 15 becomes A, B, C, D, E, F. And that's why you will see a mixture of numbers and letters in a MAC address. Later on, when you learn the conversions of hexadecimal, because that's what this is called, hexadecimal to binary, you'll understand why these values are the way they are. And you'll start to understand the binary system, and then hexadecimal, when you learn to convert them, it'll make sense. We say that it's 48 bits, which means if it's 48 bits and there's 12 numbers here, what's 12 divided into 48? That's 4, right? That's 8 and 4. So that means each one of these numbers have 4 bits in them. Now, MAC addresses are assigned automatically. You can change the MAC address numbers, but you're not changing the real number. You're just overlapping it with a logical number. Which means if this is the MAC address on here, and I put a MAC address of all ones on that MAC address, this is still the real MAC address. You can never change this number. This is hard-coded onto the network card. But the first 6 numbers, or first 6 digits of this number, is assigned by an organization called the OUI. The OUI, which is this number here, the OUI number, are these first 6 digits. So I'm Kyle Incorporated, and I call up the OUI and say, hey, guys, I want to make network cards. I want to manufacture them. They say, sure, no problem. Your number is 238490. And I say, thank you very much. And every one of my network cards must start with these first 6 digits. It must. And guess how I'm going to make my network cards? When I make my first one, it's going to be 000001. My next one's going to be 02. My next one's going to be 03. That means I made 3 network cards now. Now I'm going to get to number 9. 09. What's my 10th one's going to be? 0A. 0B. And then eventually I'm going to get up to 0F. Now, after this, what do you think the next one's going to be? You guessed it. 1 0, 1 1, 1 2, all the way down to 1 9, all the way down to 1A, all the way down to 1F, and then guess what the next one is? 2 0. See how that's going? And eventually I'm going to get all the way up to 9F. And what do you think the next one's going to be after 9F? It's going to be A0. Because this will be my 10th place, and this will drop back down to 0. Just like counting numbers, you're just using a hexadecimal. And eventually I'm going to get all the way up to EF. And what do you think the next one's going to be? F0. And then eventually that's going to go all the way up to FF. Let's take a look at our MAC address now. So here we go. Here's a MAC address. 00OC29. That's really the first number I'm looking for. I'm going to go ahead and copy that by right-clicking on it. And I'm going to say MAC address lookup. Just go right to here. OOCC 00OC29. Let's look it up. Well, check that out. VMware Incorporated. Well, now I know this is a MAC address or a network card that has a MAC address off of what? VMware. Now I know this is a VM machine. Wouldn't that be helpful? Because I'm going to tell you, VMs are kind of hard to track down when you're on a network. So here's my personal machine. Let's find out what we have here. And MAC address. I just want the first 3. Oh, that's right. I can't copy it. So that's 00. Oh, actually, I can copy it because I'm on my PCs now. There we go. 002618. ASUS computers. Now I know that I have an ASUS board. Well, at least, well, not really an ASUS motherboard, but an ASUS network card. Considering the fact that this is my own board card, most likely I have an ASUS motherboard. But nonetheless, that's how you use that tool. And it's just online, that's all. And that pretty much ends our network fundamentals. There's a lot of things you should be reviewing at this stage before you move on to the switch. Really, the major things that I want you to understand as we go back through here is obviously what a network is. Anything that is communicating that has an IP address is a network device. As long as you have more than one device on a particular media of some sort, whether it's physical, whether it's wireless or radio waves, as long as more than one PC are trying to communicate, you have a network. Obviously, you want to know that you're working on routers and switches, and that's all you're going to be doing with the CCNA routing and switching. These are only 2 devices you're going to work on. You want to understand your cable types if you're going to be getting a lab, which is your WIC 1T, your WIC 2Ts, what kind of cables you need to have, which is your DCE, DTE cables. If you want to use fiber between your devices, make sure you get the right SFP. You definitely need a console cable. Obviously, know what your network symbols are. Obviously, you want to know how it fits. You want to know where a switch will lie in your network, where a router, when you actually need a router. Ethernet, we talked about that a couple times. It's nice to know what you're definitely what these mean. We talked about this is your speed, your 10 megabits per second, and that's up to 10. Saying that now it's 10 base, and we're using twisted pair. Got your cable types, which is your Ethernet, your Giga Ethernet, Fast Ethernet, which that's what this is. This is Fast Ethernet. because it's 100 megabits per second. Your pinouts of your cables. Crossover cables isn't really necessary to really understand the pins. I personally would. I would definitely memorize that 1 and 2 and 3 and 6 are transmitting. As part of your communication, and 1 and 2 are transmitting and 3 and 6 are not. 3 and 6 are receiving. I would definitely commit that to memory just for your field purposes when you're at work. Never know. Especially when you're on the knock. You never know who will be your site support. Know where your devices sit. At what layer. Routers are layer 3. Switches are layer 2. Hubs are not layer 2. They're layer 1. However, there's lots of people that say it's at layer 2 because it's on an Ethernet segment. And network cards are layer 3. And bridges are layer 2. Understand what an IP address is. The fact that it's made up of 4 numbers. Understand what your MAC address is. Understand that it's made up of 12 numbers. This is how your PC will read them or display them. This is how Cisco displays them. There'll be 4 numbers in each section separated by 2 dots. In Chapter 2, we talked about the OSI model. And I think we've done this heavily enough for you to understand what's layer 2 and what's layer 3. We talked about the OSI communication. We talked about how our PC builds those layers for every bit of communication going out. So remember, if I need to send 10 packets, I need to do this 10 times. It's not just once and then we're finished. It's for every piece of data that goes out. If you're using TCP for your communication, you're going to be using the layer 4 as well. And getting sequence numbers and acknowledgement numbers back. We compared the OSI model to the TCP model. We talked about TCP IP, the application suite. We definitely talked about the 3-way handshake. We talked about the header of the TCP, the UDP header. We definitely talked about windowing. Talked about our sequence numbers plus our windowing. We talked about multiplexing a little bit. Definitely talked about port numbers. Definitely talked about communication types, which is our unicast, multicast, anycast, and broadcast. We talked about our communication basics, which got kind of complicated, even though it's basic. We never really went through the flow chart down here, which really isn't necessary. I usually do this for my classes. And we talked about our network types, our LAN devices and where they fit, how far our LAN goes. Talked about IEEE, the data link layer, Ethernet, carry sense multi-access collision detection, our broadcast and collision domains, and our basic formats of MAC addresses. And guys, that's it for network fundamentals.